Welcome to the Explainer. Today, we're prying open the digital toolbox to get a look at the powerful, super flexible databases that really make the modern internet work. So, when you're scrolling through your favorite app, ever just stop and wonder, how in the world does this thing not crash with millions of us on here right now? Well, that little piece of engineering magic, that's exactly what we're diving into today. All right, so let's get into it. And, to really get the new way, you got to understand the old way first. Traditional databases were like a super, super strict spreadsheet. Everything had its place, right? Neat little rows, neat little columns. But the modern web is, well, it's messy. And trying to cram all that messy data into a rigid box, yeah, that's like trying to build a killer spaceship using only the boring square Legos. It just doesn't work. And really, that's the core of the problem. See, the internet just blew everything up. All of a sudden, you had this insane explosion of data, social media feeds, user profiles, what's in your shopping cart. It was all over the place, totally unpredictable, and there was just so much of it. The old systems, they just weren't designed to handle this kind of, this beautiful chaos. So this new world needed a new superpower, and that superpower is called scalability. It sounds fancy, but it's a really simple idea. When your app blows up and gets super popular, how do you handle all those new users and all their data without the whole thing just falling apart? Simple. You need a way to easily add more muscle. And there are basically two ways to do that. The old way was called scaling up. It's like having one massive, super powerful computer and just keep making it bigger and more powerful. Problem is, that gets crazy expensive, and eventually, you just hit a wall. There's a hard limit. The new way, that's scaling out. Instead of one giant machine, you just add a bunch of normal, cheaper computers that work together as a team. And that right there, that's the secret sauce for NoSQL. These databases were built from day one to scale out, which means they can grow almost forever. Okay, let's pop open that toolbox. Tool number one is the key value store. This is the simplest one, the most streamlined. Its whole reason for existing can be summed up in one word: speed. And the analogy for this is just perfect. It's a digital coat check. Seriously, you hand something over, that's your value, and you get a little ticket back. That's your key. Want your stuff back? Just show the ticket. That's it. The system doesn't care what the code is, it just needs the ticket to find it. And because it's so simple, it is insanely fast. And that's precisely why it's so powerful. It's perfect for stuff that needs to be found in a split second, like caching data to make a website feel snappy. So how does it scale? Well, what do you do at a busy code check? You just open another window. It's the same idea here. You just add more servers and boom, you can handle more traffic without slowing down. All right, on to tool number two in our kit, the document database. Now, if the last one was all about raw speed, this one is all about being flexible. It's about making a developer's life a whole lot easier. The best way to picture this is a digital filing cabinet. So instead of having to chop up all of a user's info and store it in a bunch of different spreadsheets, you just put everything about them, their profile, their purchase history, their likes and dislikes, all of it goes into one single neat folder, a self-contained document. And for developers building apps, this is a total game changer. It makes so much sense for things like user profiles or e-commerce catalogs. And what about scaling? Well, what do you do when your office runs out of space? You just buy another filing cabinet, right? Same thing here. You just add more servers, spreading those cabinets out. It's that classic horizontal scaling we talked about. Okay, tool number three. This is the big one, the heavy hitter. We're talking about the wide column store. You bring this one out when you have just truly staggering amounts of data. Think about the data from millions of IoT devices, or logging every single click on a massive website. So to get why this one's so cool, we have to go back to our plain old spreadsheet again. See how every row has to have the exact same columns? User 101 has a name, an email, and a login. That means user 102 has to have space for those same things, even if you don't have the info. It's very rigid. But now, look at this. Our super spreadsheet. Alice has a column for favorite color, but Bob doesn't need one. And hey, Bob's got a top score, but Alice doesn't. Get it? Every single row can have its own totally unique set of columns. That kind of flexibility is just mind-blowing when your data isn't all the same. And that is why this beast was built from the ground up for big data. Its whole job is to take these gigantic, sprawling tables and chop them up efficiently across, hundreds, even thousands of regular servers. There's a reason it's the backbone for so many huge analytics platforms. Okay, our last tool is something else entirely, a graph database. This one isn't so much about storing the things themselves. It's about storing the connections between them. And trust me, this is where it gets really interesting. You know, in the movies, the detective's corkboard with all the pictures and strings connecting them, that's a graph database. The pictures of people and places, those are called nodes. And the strings connecting them with little notes like, knows this person or was here, those are the edges. It literally stores data as a web of relationships, which is just brilliant for navigating complicated networks. And this unique way of thinking opens up some seriously powerful possibilities. I mean, what is a social network? It's a giant graph of people and their connections. Or those recommendation engines, you know? Customers who bought this also like that? That's a graph in action. Trying to answer those kinds of questions with a regular database can be painfully slow. But for a graph database, that's what it was born to do. Okay, let's pull back for a second. We've just seen 4 really different, really powerful tools in our NoSQL toolbox. And the biggest takeaway, the thing I really want you to remember, is this. There is no one best database. It's always about picking the right tool for the specific job you're trying to do. So let's run through them one last time. You've got the key value store, or super fast code check, the document store, the flexible filing cabinet, the wide column store, the massive super spreadsheet, and the graph database, or relationship map for finding hidden connections. Each one is a specialist, a master of its craft, and all of them are designed around that key idea of scaling out. And this quote here just nails it. The point of NoSQL wasn't to throw out the old databases. It was about expanding the toolbox. It's about letting developers pick the perfect data model for their problem instead of trying to force everything into one kind of box. And that means they can build things faster and handle massive amounts of data way more efficiently. So I want to leave you with a final thought. Next time you open your favorite food delivery app, just pause for a second and think, how are they storing all those restaurants and menus? Where does your own user profile and past orders live? And what's figuring out the fastest delivery route? The answer, almost certainly, is that they're using a mix of these very tools. A document database here, a graph database there, all working together behind the scenes. And that, right there, is the real power of having a full digital toolbox.